Hello students. Today my topic of presentation is Poisson distribution. In this topic I will discuss today definition, formula, notation, parameter, properties, characteristics, and finally I will discuss the application of Poisson distribution. Here is a flow chart of Poisson distribution. Probability distribution. Here is a flow chart of probability distribution which has two types of discrete and continuous. There are three types of discrete probability distribution: binomial, Poisson, hypergeometric, and normal distribution is a type of continuous probability distribution. Here is a definition of Poisson distribution. Poisson distribution is the discrete probability distribution for the numbers of events that occurs randomly in a specific time interval. It is a theoretical type of probability distribution. Poisson distribution is used when n goes to very large, that is n goes to infinity, and p, probability of success, is very small, p goes to 0. Poisson distribution was first introduced by French mathematician Simon Denis Poisson in 1837. At first, it was derived as an approximation to the binomial distribution. Purpose of Poisson distribution is to describe the probability of a number of events occurring in a given time or space interval. Now, I will discuss the formula of Poisson distribution. Here is the formula of Poisson distribution. P denotes the probability, x, number of success, mu, mean, mu raised to power x, e raised to power minus mu divided by x factorial. Now, here is the notation. X is equal to 0, 1, 2, 3. X always start from 0. In Poisson distribution, x always start from 0 to 3. X doesn't start from the negative values because Poisson distribution doesn't consider the negative values. The actual number of successes that occur in a specified, what is x? The actual number of successes that occur in a specified region. And what is the mu? Mu stands for the mean number of occurrences that occur in a specified region. E. What is E? E stands for Euler's constant, and 2.71828 is the understood value of E. What is X? X stands for actual number of successes that occur in a specified region. Now, I will discuss the parameter of Poisson distribution. There is only one parameter of Poisson distribution named as mu. Now, I will discuss mean and variance. Mean and variance of the Poisson distribution are both equal, which is mu. Expectation of x is equal to mu, and variance of x is equal to mu. Standard deviation of x is equal to square root of mu. Students, we know that mean and variance of the Poisson distribution is same. If we find the standard deviation of the Poisson distribution, Then we take the square root of the variance. For example, variance of x equal to mu. If we need a standard deviation, then we take square root of mu. We get this is a standard deviation. But if we want to find the variance from the standard deviation, then here we suppose that standard deviation of x equal to square root of mu. Then we take whole square for variance. We apply whole square on both sides. Its square has been cancelled out from the square root. Then we get just a mu. This one. Always remember that variance is the square of standard deviation, and standard deviation is the square root of the variance. Properties of the Poisson distribution. There are the following properties of Poisson distribution. The outcomes of an experiment can be classified as success and failures. The mean mu that occurs in a specified region is known. The number of trials is very large and goes to infinity. The probability of success P in each trial is very small, that is P goes to 0. Characteristics. Here we discuss the characteristics of Poisson distribution. Poisson distribution is a discrete distribution. Each occurrence of one event is independent of the occurrence of other event. It means that both events do not depend each other. The range of the occurrences in each interval can be 0 to infinity. The average mean number of occurrences must be constant in whole experiment. For example, you take mu equal to 2. You can take lambda. You can take lambda, and you can take also m, n, etc. You can take any variable for mean, for average. When you take mu equal to 2, then it will remain constant in whole experiment. Now, finally, we will discuss the application of Poisson distribution. The number of misprints in a book. The number of bacteria in a glass. The number of traffic accidents in a city. The number of infinite breaths in a city. The number of persons who are infected with coronavirus in a city. All these are the examples of Poisson distribution. Thank you, students.